Hi there, welcome to Ancient Cosmos Sleep. Tonight we find ourselves standing at the edge of something your everyday thinking quietly assumes is solid, reliable, and utterly unquestionable. Time itself. You feel it right now, don't you? That soft illusion of now, sliding into then, like a river carrying everything forward, whether you agree or not. Except tonight, we're going to gently mess with that feeling. Not violently, not dramatically. More like quietly lifting one corner of reality and peeking underneath, just to see if anything is actually moving at all, out here in the dark, where your room is still and your thoughts get slightly louder. The idea that time might not be passing starts to feel less like philosophy and more like a mildly unsettling prank the universe is playing on you. And honestly, you probably won't survive this realization in the emotional sense. Don't worry, nobody does. It just means you'll start noticing weird cracks in how you experience existence, like a clock ticking without any real tick happening in reality. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Just kidding. Your attention span is safe with me. Tell me in the comments where you are in the world and what time it is for you right now, because it's oddly comforting to imagine thousands of people all trapped in different nows, while we talk about how none of them might actually exist. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You might think time is the simplest thing in your life. Wake up, eat, work, sleep, repeat. A straight line, predictable, almost boring. But even ancient thinkers weren't convinced. A mainstream historical fact. The ancient Egyptians used shadow clocks as early as 1500 BCE, carefully tracking the sun's movement to divide the day into parts, believing time was tied to divine order. Meanwhile, a quirky fringe idea from later Greek philosophy suggested time might be an illusion born from human perception, a kind of mental projection rather than something external. Historians still argue whether early timekeeping was meant more for spiritual alignment or practical scheduling, and that debate quietly echoes into modern physics more than you'd expect. As you sit there, imagine those early observers watching a stick's shadow creep across stone, convinced they were witnessing time itself move. But all they were really watching was Earth turning, light shifting, and their own minds filling in the gaps. You've probably done something similar without noticing, glancing at a clock and feeling late or early, as if those are properties of reality, not interpretation. And yet, even that simple assumption starts to wobble when you look closer. Because if time is truly passing, where exactly is it going? You don't see it leaving. You don't see it arriving. You only ever catch snapshots, like flipping through a book so fast you assume the pages are moving on their own. The deeper you go into this thought, the more you start to suspect something strange. Maybe time isn't a river at all. Maybe it's the book itself already written, with your consciousness just moving across the pages. But that's a disturbing idea. So for now, we'll stay with shadows and ancient clocks and let your mind adjust slowly, like eyes adapting to a darkened sky. And somewhere between those shadows and your heartbeat, the question begins to form, not loudly, not urgently, but persistently. What if nothing is actually flowing at all? You've just stepped out of the world where shadows measured time and into something even stranger. The realization that humans have always been trying to cage something that refuses to be held. It's a bit like trying to bottle wind, or trying to convince a river it should behave like a staircase. Ancient civilizations didn't have the luxury of thinking time might be weird. A mainstream historical fact. The Babylonians developed one of the earliest systems of dividing time into base 60 units, which is why you still have 60 seconds in a minute today. That system wasn't random. It was tied to astronomy, trade, and the belief that celestial order reflected divine structure. Meanwhile, a quirky fringe tidbit from later medieval thought suggested that angels might move outside time entirely, observing human life as a single unchanging object. Historians still argue whether these systems were primarily mathematical breakthroughs or deeply spiritual frameworks disguised as measurement. So you walk through mental history and notice something funny. Every culture builds clocks, but none of them agree on what time actually is. They only agree on how to slice it. Picture a Babylonian priest tracing shadows on a wall, carefully converting celestial motion into numbers. He believes he is measuring time itself, but what he is really measuring is repetition. Cycles of light, cycles of shadow, cycles of expectation. And you, sitting here centuries later, still rely on the same illusion packaged in more precise technology. Modern clocks are just more confident lies. They tick with atomic precision, slicing reality into smaller and smaller pieces, convincing you that those pieces are real units of something flowing. But nothing in physics actually requires flow. It only requires change. And that distinction is where things start to bend, because change doesn't imply movement through time. It only implies difference between states. A cup breaking, a star collapsing, your phone battery draining. None of these require time to move forward. They only require that one state follows another in description. It sounds subtle, but it's the kind of subtle that makes physicists lose sleep, a mainstream scientific fact. Newtonian physics originally treated time as absolute and universal, the same everywhere in the universe, ticking evenly like a cosmic metronome. But that idea started cracking under closer observation of light and motion. A quirky fringe interpretation that emerged later suggested that Newton himself may have suspected time was more of a mathematical convenience than a physical entity. Historians still argue whether Newton's writings imply genuine belief in absolute time or just pragmatic modeling. And now, as you drift deeper into this idea, you begin to notice how deeply your mind depends on that assumption. Every plan you make, every memory you recall, every before and after is built on the idea that time is something external you are moving through. But what if you are not moving through anything at all? What if you are simply existing as a sequence of states, like frames in a film reel, while your mind insists there must be a projector somewhere pushing the film forward? That metaphor starts to feel too real after a while. You might even feel a slight discomfort, like your thoughts are lagging behind something they can't quite see. But we're still only in the early layers of this idea. Because the real rupture comes when physics stops treating time as universal altogether. And that's where Einstein quietly enters the room, rearranges everything without asking permission, and leaves you with a universe that no longer agrees on what now means. Now you're no longer just questioning clocks or ancient civilizations. You're stepping into a universe that refuses to keep its story consistent. A universe where now is not a shared experience, but a personal opinion depending on how fast you're moving or how deep you are inside gravity's grip. a mainstream historical fact. In 1905, Albert Einstein published his special theory of relativity, showing that time is not absolute but depends on the observer's motion. That single shift shattered the idea of a universal clock ticking the same for everyone. Meanwhile, a quirky fringe interpretation from early 20th century thinkers suggested that Einstein had unlocked a hidden geometric dimension rather than discovered a physical property, almost like time was a coordinate rather than a substance. Historians still argue whether Minkowski's latest spacetime formulation was a natural evolution of Einstein's work or a conceptual leap that even Einstein initially resisted. And here is where things get quietly unsettling, because once you accept that motion affects time, you can never go back to thinking of time as stable. Imagine two people. One stays on Earth, casually living their life. The other travels on a spaceship moving near the speed of light. When they reunite, they are no longer the same age. Not metaphorically, literally. One has experienced less time than the other, but notice something strange. Neither of them felt time breaking. Each experienced their own present as normal. Their clocks, their thoughts, their heartbeat, all perfectly consistent within their own frame. So where is the real now? There isn't one. Instead, there are slices, layers of reality stacked at angles, like pages in a book that don't agree on which page is currently being read. This is where relativity quietly dissolves the comforting idea of a shared present. You can no longer point to the universe and say, "This moment is happening everywhere." The universe refuses to cooperate with that sentence, a mainstream scientific fact. Experiments with extremely precise atomic clocks flown on airplanes have confirmed time dilation effects predicted by relativity. Clocks at different velocities tick at different rates. Meanwhile, a more speculative fringe idea suggests that consciousness itself might be what stitches these differing time rates into a single perceived flow. Though there is no experimental support for this, historians still argue whether early critics of relativity rejected it for scientific reasons or because it conflicted with deeply ingrained philosophical intuitions about time. And now, as you sit with this, something subtle begins to shift in how you imagine reality. You start to picture time not as a river, but as a landscape. Not something you move through, but something you observe from different angles depending on your motion. A frozen architecture of events. And if that's true, then the sensation of flow. You feel every second of your life might not be describing the universe at all. It might only be describing you, because in relativity, nothing actually moves forward in time in a universal sense. Instead, different observers simply disagree on how slices of reality line up, and yet your brain still insists on a smooth narrative, a continuous unfolding, a gentle progression from past to present to future. That insistence becomes more mysterious the longer you think about it, because physics no longer guarantees it. So now you're left with a strange possibility. Maybe time doesn't pass at all. Maybe what passes is only your perspective through a structure that was already fully formed. And somewhere inside that idea, Einstein's universe stops feeling like a story and starts feeling like a map you were never meant to interpret as motion. You continue drifting through this peculiar landscape, and the more you look around, the less it resembles the familiar world of ticking clocks and turning calendar pages. What once felt like a smooth current now begins to resemble a vast structure, quiet, motionless, and strangely complete. a mainstream historical fact. In 1908, the mathematician Hermann Minkowski introduced a revolutionary way of viewing reality. Instead of treating space and time as separate things, he combined them into a single framework called spacetime. His famous declaration was that space by itself and time by itself would fade into shadows, and only their union would preserve an independent reality. At first glance, that sounds like the sort of sentence a mathematician writes after spending too much time indoors with equations. But the implications are enormous, because once space-time enters the picture, the universe begins to look less like a movie and more like a sculpture. Imagine an entire human life, not just this evening, not just this year, every moment, your first breath, your first step, the day you learned to ride a bicycle, the moment you discovered some embarrassing photograph of yourself from years ago. Even this very second, in the space-time picture, all of those events exist as locations in a four-dimensional structure, not memories, not possibilities, locations. You don't become older in space-time any more than a road becomes longer because you walk along it. The road already exists. You simply experience different parts of it. This idea is often called the block universe. The name sounds suspiciously like something invented by a science fiction writer who had misplaced their imagination in a geometry textbook. Yet it emerges naturally from relativity. In the block universe, the past is not gone. The future is not missing. Both are equally real parts of space-time. The sensation that one moment replaces another may exist only inside conscious experience. Pause there for a moment. If your future already exists in the structure of space-time, then tomorrow is not being created. It is already present as a different region of reality. That thought tends to make people slightly uncomfortable. Not because it is necessarily wrong, because it challenges nearly every instinct you possess. After all, your daily experience tells you that the future does not exist yet. You make choices, you feel uncertainty. You wonder what happens next. And uncertainty certainly feels real. But uncertainty does not automatically prove that the future itself is unreal. If you have never visited a city, the streets still exist before you arrive. Your ignorance of them does not erase them. A quirky fringe tidbit appeared in the 20th century, when some philosophers compared the block universe to a gigantic cosmic novel. Every page exists simultaneously, but the reader experiences the story one page at a time. Critics immediately pointed out that this analogy raises another question: who or what is the reader? Historians still argue whether the block universe is best understood as a literal description of reality or merely a useful interpretation of relativity. And that debate remains remarkably alive, because the block universe solves certain puzzles beautifully. For example, relativity tells us that different observers can disagree about which distant events are happening right now. If there is no universal present, then perhaps the idea of a special moving now was never fundamental in the first place. The block universe handles this elegantly. Every event simply exists. No cosmic spotlight sweeps across space-time declaring one slice to be the official present. No universal clock hangs above the cosmos announcing the current moment. Reality simply is. Meanwhile, your consciousness moves through experiences in a way that creates the impression of passage, or at least that's one interpretation. And here is where the thought becomes wonderfully strange. Imagine the universe as a gigantic mountain range. Every peak, valley, cliff, and river already exists. Now imagine a tiny beam of awareness sweeping across that landscape. The mountains are not appearing. The beam is merely encountering them. Likewise, perhaps your birth, childhood, adulthood, and final days all coexist within space-time. Nothing is coming into existence. Nothing is leaving existence. Your awareness simply encounters different locations along your world line. That term, world line, is important. In relativity, every object traces a path through space-time. A planet has a world line. A photon has a world line. You have a world line from birth to death. Your entire history forms a continuous geometric structure, not a process, a structure. And if that sounds a little eerie, you're not alone. Even Einstein found comfort in this perspective after personal loss. When his friend Michele Besso died, Einstein wrote that for those who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. It's one of the most famous statements ever written about time, and perhaps one of the most haunting, because if he was right, then the moments you think have vanished are not truly gone. The afternoon sunlight from your childhood, a forgotten conversation, a laugh you can barely remember. Those events do not disappear from space-time. They remain embedded within the structure, permanent, unmoving, still there, like footprints preserved in stone, of course. This raises difficult questions about free will. If the future already exists, can you genuinely choose anything? A mainstream historical fact is that philosophers have debated versions of this question for thousands of years, stretching back to thinkers in ancient Greece and beyond. Some argue that a fixed space-time implies determinism. Others argue that free will and a fixed space-time might coexist in ways we do not yet understand. Historians still argue whether ancient debates about fate anticipated modern discussions about space-time and determinism. And for tonight, we won't try to settle that argument. We're simply wandering through the landscape, looking around, noticing how different reality appears when you stop imagining time as a flowing river. Because the deeper you travel into this idea, the harder it becomes to find the flow at all. You find events, you find relationships between events, you find geometry, you find structure, but the passage itself remains strangely absent, like a sound everyone hears but nobody can locate. And just when you begin adjusting to that unsettling possibility, physics prepares another surprise, because even if space-time is real, even if the block universe exists, there remains a profound mystery. Why does your experience feel so strongly as though time is moving? Why does consciousness seem to slide from one moment to the next instead of perceiving everything at once? That question waits quietly ahead, like a distant lantern in the dark, while the frozen landscape of space-time stretches endlessly around you. The frozen landscape remains around you. Past events sit where they always sat. Future events rest where they always rested. Nothing appears to be moving, and yet your experience stubbornly insists that something is. You feel moments arriving. You feel moments leaving. You feel yourself traveling through life as naturally as a boat drifting down a river. And that brings you to one of the strangest places in modern science, the world of quantum physics, a mainstream historical fact. In the early 20th century, physicists such as Max Planck, Niels Bohr, and Werner Heisenberg developed quantum theory to explain behaviors that classical physics simply could not account for. Their work transformed science and revealed a microscopic world far stranger than anyone expected. If relativity made time feel unstable, quantum physics makes it feel almost negotiable. At the scale of atoms and particles, many of the assumptions that guide ordinary life stop working. Objects do not always possess definite properties before measurement. Outcomes become probabilities. Cause and effect remain intact, but the picture becomes blurry in ways that still provoke arguments more than a century later. And right in the middle of that confusion sits time. Interestingly, quantum mechanics often treats time differently from space. Space becomes part of the system being studied. Time usually enters from outside, like a background stage on which events occur. That might sound harmless, but it creates a serious tension. Relativity tells you that space-time is a unified structure. Quantum theory often behaves as though time is special. It is as if two brilliant musicians have been handed different versions of the same song. Both performances sound convincing, yet somehow they do not quite fit together. Physicists have spent decades trying to reconcile them. The challenge remains unsolved. A quirky, fringe tidbit emerged from some interpretations of quantum gravity. In certain formulations, equations describing the universe seem to function perfectly well without time appearing at all. Time simply vanishes from the mathematics. Not hidden, not disguised, gone. This discovery startled researchers. After all, if a theory of the universe works without time, then perhaps time is not fundamental, perhaps it emerges from something deeper, like temperature emerging from countless moving molecules, or like a wave emerging from countless water particles. Historians still argue whether early pioneers of quantum theory anticipated such radical conclusions, or whether these ideas represent a genuine departure from their original intentions. As you continue wandering through these concepts, the universe begins to resemble an enormous puzzle assembled from pieces that almost fit. Relativity says space-time is a complete structure. Quantum theory hints that time may not be fundamental. Both ideas point toward a surprising possibility. The flow of time may not exist at the deepest level of reality. Now, before your sleepy brain decides to file a formal complaint, let's slow down. This does not mean clocks stop working. Your alarm clock will still find ways to ruin peaceful mornings. Trust me, quantum mechanics has not yet developed enough compassion to prevent Monday mornings. But it does mean that what you experience may be very different from what fundamentally exists. Consider a flip book. You draw a stick figure on dozens of pages. When the pages flip rapidly, motion appears, yet no individual page contains movement. The motion emerges from the sequence. Perhaps time is similar. Perhaps the universe consists of relationships among states, while the sensation of flow emerges from how conscious systems process those states. Some physicists find this possibility attractive. Others remain skeptical, and the debate grows even more fascinating when consciousness enters the discussion. Certain speculative theories suggest that awareness itself might play a role in creating the feeling of temporal passage. Most researchers remain cautious about such claims because evidence is limited. Nevertheless, the possibility continues to inspire both scientists and philosophers. Imagine a library containing every page of a story. The entire narrative already exists. Nothing is being written. Nothing is changing. Yet a reader moving through the pages experiences suspense, surprise, and anticipation. The story feels alive. because the reader encounters information sequentially, not because the pages are being created. That image returns again and again in discussions about time. And perhaps there is a reason for that, because your experience resembles a reader's experience more than you might initially realize. You never encounter your entire life simultaneously. You encounter one perspective after another, one memory after another, one perception after another. The sensation of movement may arise from the ordering of those experiences rather than from any actual cosmic flow. A mainstream scientific fact supports at least part of this idea. Modern neuroscience shows that your brain continuously integrates sensory information over short intervals, constructing a coherent experience from many incoming signals. What feels like an immediate present is already a carefully assembled interpretation. That realization carries an oddly comforting quality. You often imagine yourself standing inside time, but perhaps you are standing inside something larger, something structured, something complete, and your awareness is simply navigating it. Not unlike a traveler moving through a vast museum after closing hours. The exhibits do not rearrange themselves. The traveler changes position. Of course, none of this proves that time is unreal. Far from it. Many physicists believe time remains fundamental. Many others think it emerges from deeper laws. Still others suspect we are missing a crucial piece of the puzzle entirely. The mystery remains open. Yet one thing becomes increasingly difficult to ignore. Whenever scientists push toward deeper descriptions of reality, the familiar flowing river of time becomes harder to locate. It begins to dissolve into geometry, into information, into relationships, into probabilities, into mathematical structures that function surprisingly well without requiring a universal ticking clock. And that observation leads naturally toward another question. If the flow of time is not fundamental, why does the universe appear to possess a direction? Why do eggs break but never spontaneously reassemble? Why do memories point toward yesterday instead of tomorrow? Why does experience seem oriented one way rather than the other? Somewhere ahead lies the clue physicists call the arrow of time, and unlike many mysteries we've encountered tonight, this one hides in plain sight, scattered across cooling coffee, fading stars, messy bedrooms, and every sock that has ever vanished from a laundry basket under suspicious circumstances. The strange thing about time is that even after relativity stretches it and quantum theory questions it, your everyday experience still feels stubbornly one-directional. You remember breakfast. You do not remember next Tuesday. You watch ice cubes melt. You never open the freezer and discover a puddle thoughtfully rebuilding itself into a perfect cube. Something about reality appears to have a preferred direction. And this is where you encounter one of the most important ideas in modern physics, the arrow of time, a mainstream historical fact. In the 19th century, physicists such as Ludwig Boltzmann helped develop the science of thermodynamics, which studies heat, energy, and entropy. Their work revealed that many natural processes tend toward increasing disorder, a principle that became deeply connected to our understanding of time's apparent direction. Entropy sounds intimidating, but the basic idea is surprisingly simple. Imagine a neatly organized deck of cards. Now throw the cards into the air. The organized arrangement becomes disordered very quickly. The reverse rarely happens. You never toss a chaotic pile of cards into the air and watch them land in perfect numerical order while politely applauding themselves. The universe seems to prefer disorder, not because disorder is magical, because there are vastly more ways for things to be messy than orderly. This tendency is measured by entropy. And according to the second law of thermodynamics, entropy in an isolated system tends to increase. That simple statement may explain why time feels as though it moves forward. Notice the wording carefully, not why time moves forward, why it feels that way. Because the equations governing many microscopic physical processes work almost equally well forward and backward. If you watch two billiard balls collide, a video of the collision often looks plausible whether played normally or in reverse. The underlying laws don't strongly care about direction, yet large-scale reality does. Coffee cools, buildings age, stars burn fuel, you grow older, entropy rises, and from that rise emerges a sense of direction. A quirky fringe tidbit appeared in Victorian scientific circles when some thinkers speculated that entire regions of the cosmos might experience time in reverse. Most modern physicists do not support such ideas in their original form, but the notion highlights how puzzling entropy has always been. Historians still argue whether 19th century debates about entropy were primarily scientific discussions or philosophical reflections disguised as physics. Now imagine the universe shortly after the Big Bang. The cosmos was incredibly hot and dense. Yet remarkably, it also possessed extraordinarily low entropy relative to what was possible. This fact remains one of the great mysteries of cosmology, because if entropy naturally increases, why did the universe begin in such an ordered state? Nobody knows for certain, and that mystery sits at the heart of the arrow of time. Think about it this way. Suppose you enter a room and find 1,000 puzzle pieces perfectly assembled into a beautiful image. You immediately suspect someone arranged them. But if you enter a room and find 1,000 pieces scattered across the floor, you aren't surprised at all. Order feels special. Disorder feels ordinary. The early universe appears to have been astonishingly special, and that special beginning may be the reason you experience a distinction between past and future today. The consequences reach everywhere. Your memories depend on entropy. Writing information into a brain requires physical processes. Those processes generate entropy. Memory itself points toward lower entropy conditions because it records traces of events that occurred earlier. You remember yesterday because physical evidence of yesterday exists within your brain. You do not remember tomorrow because evidence from tomorrow has not been encoded, at least not yet, which is probably fortunate. Imagine trying to remember every future awkward conversation in advance. Most people already have enough anxiety without receiving spoilers from next Thursday. As you drift deeper into this idea, the arrow of time begins to look less like a fundamental feature of reality and more like a consequence of cosmic history. The universe may not contain a built-in flow. Instead, it may contain a built-in gradient, a difference between low entropy and high entropy. And conscious creatures experience that gradient as temporal direction. A mainstream scientific fact. Modern cosmology strongly supports the idea that entropy has generally increased throughout cosmic history, from the early universe to the formation of stars, galaxies, planets, and complex structures. Yet the reason for the universe's extraordinarily low entropy beginning remains unresolved. This unresolved question has inspired countless theories. Some researchers propose that inflation, The rapid expansion of the early universe plays a role. Others suggest deeper laws remain undiscovered. Still others argue that the arrow of time may emerge from statistical principles we do not yet fully understand. Historians still argue whether future generations will view the entropy problem as one of physics' greatest mysteries or simply a puzzle awaiting a straightforward solution. And somewhere between those possibilities, your own experience continues. You breathe in, you breathe out, thought follows thought, memory follows memory. The sequence feels natural. Yet beneath that natural feeling, a possibility quietly grows. Perhaps what you call the passage of time is actually your movement along an entropy gradient. Perhaps the universe isn't flowing. Perhaps it is simply unfolding according to patterns established near its beginning, like a melody whose notes already exist in the score. The music feels as though it travels forward, but the sheet itself remains still. That image becomes increasingly important, because soon you'll travel back toward the earliest moments of the cosmos itself, toward the event that appears to anchor every clock, every calendar, every memory, every star, the beginning of the observable universe. And there, at the edge of our understanding, you'll discover that even asking when time began may be more complicated than it sounds, because if time has never truly passed, then perhaps the first moment was never really a moment at all. The melody continues, the notes seem to arrive one after another, and yet the sheet of music remains perfectly still. That image follows you now as you drift farther backward, past civilizations, past clocks, past memories, past stars themselves, toward the deepest horizon modern science can currently examine, the beginning of the observable universe, or at least what appears to be the beginning. A mainstream historical fact. In 1929, Edwin Hubble published observations showing that distant galaxies are moving away from one another. The farther away a galaxy appeared, the faster it seemed to recede. This discovery provided crucial evidence that the universe is expanding. And if the universe is expanding today, then reversing the process leads to an extraordinary conclusion. Everything was once closer together, farther back still, closer, denser, hotter, until eventually the mathematics points toward a state of astonishing compression, what we now call the Big Bang. The name itself sounds dramatic, almost explosive, as though someone set off cosmic fireworks and accidentally created existence. The amusing part is that the term Big Bang originally gained popularity, partly because critics used it dismissively. Coins occasionally advances through serious equations and accidental branding. Humanity remains wonderfully consistent. Now picture the observable universe shrinking, galaxies disappear into one another, clusters merge, distances collapse, stars vanish into an increasingly dense cosmic fog. Eventually the familiar structures of the cosmos cease to exist. No planets, no galaxies, no black holes, no you, no clocks. Just a universe compressed into conditions so extreme that our current theories begin struggling to describe them. And here a profound question emerges. What happened before the Big Bang? It sounds simple. Children ask it. Adults ask it. Scientists ask it. Yet the answer may be stranger than anyone expects. Because according to standard cosmology, time itself appears intertwined with the Big Bang. Not merely events within time. Time, a mainstream scientific fact. Modern cosmological models based on general relativity suggest that space and time are linked components of space-time. Extrapolating backward leads toward a boundary where our current understanding breaks down. Often associated with the earliest moments of the universe, notice the problem immediately. If time originates with the Big Bang, asking what happened before it may resemble asking what lies north of the North Pole. The question assumes a direction that may not exist. There may be no before in the ordinary sense, not because something blocks access, because the concept itself loses meaning. That realization has fascinated and frustrated generations of physicists. A quirky fringe tidbit comes from certain speculative cosmological models proposing that our universe emerged from a previous cosmic phase, perhaps even a previous universe. Some versions imagine endless cycles of expansion and contraction. Others suggest our cosmos formed inside a larger multiverse. None have been confirmed, but they demonstrate how creative scientists become when confronting the limits of knowledge. Historians still argue whether future discoveries will preserve the Big Bang as an absolute beginning or reinterpret it as merely one chapter within a much larger cosmic story. As you rest with these possibilities, something curious happens. The farther back you travel conceptually, the more difficult it becomes to separate space from time. In everyday life, they feel different. You move through space voluntarily. You move through time involuntarily. Nobody has ever overslept and accidentally arrived 3 Tuesdays early, at least not officially. Yet relativity treats space and time as aspects of a unified structure. And near the earliest moments of the universe, that unity becomes impossible to ignore. Some theories suggest that space-time itself emerged from deeper ingredients, not space first, not time first, something more fundamental giving rise to both. Imagine asking whether the left side of a coin existed before the right side. The question feels odd because both sides emerge together as aspects of a single object. Likewise, space and time may have originated simultaneously from a deeper reality. If so, debates about which came first could be missing the larger picture entirely. This possibility has attracted increasing attention because many attempts to unify quantum mechanics and gravity point towards structures beneath space-time, networks of information, quantum relationships, mathematical connections. The details vary dramatically between theories, but the recurring theme is striking. Time may not be fundamental. It may emerge, like temperature, like pressure, like a wave arising from countless underlying interactions. And if time emerges, then perhaps its apparent passage emerges too. The river may be an illusion generated by deeper currents we do not yet fully understand. A mainstream scientific fact. Several modern approaches to quantum gravity investigate whether space-time itself could be emergent rather than fundamental. While no consensus exists, the idea remains an active area of research. As your imagination lingers near the beginning of the cosmos, another thought begins to form. The Big Bang is often pictured as an event in time, a starting gun, a first tick, a cosmic opening scene. But perhaps that image is misleading. Perhaps the Big Bang represents not the beginning of a timeline, but the boundary of a structure, a limit beyond which our current descriptions fail. Like standing at the edge of a map, the blank region beyond does not necessarily indicate nothingness. It may simply indicate ignorance. Humanity has encountered such edges before. Ancient sailors feared the ends of oceans. Early astronomers imagined crystal spheres. Later generations discovered larger realities waiting beyond perceived boundaries. The universe has a habit of being bigger than expected, and stranger, especially when time enters the discussion, because now you find yourself holding two possibilities simultaneously. Perhaps time truly began with the Big Bang, or perhaps time emerged from something deeper. Either way, the familiar image of a universal clock steadily ticking from a cosmic starting point feels increasingly inadequate. The deeper you travel, the less you find a flowing timeline. Instead, you encounter structures, relationships, geometries, boundaries, pause. And somewhere ahead, among the most extreme structures known to science, lies an object that pushes these ideas to their limits, a place where clocks nearly stop, where gravity reshapes space-time itself, where the distinction between motion and stillness becomes strangely blurred. A black hole waiting quietly in the dark. The black hole waits in the darkness ahead, not glowing, not announcing itself, not behaving like the dramatic cosmic vacuum cleaner often portrayed in movies. Real black holes are far stranger than that. They are regions of space-time so intensely warped that ordinary intuition simply gives up and goes home. And for our journey tonight, they offer something particularly valuable. A glimpse of what happens when time itself begins to behave in ways that seem almost impossible, a mainstream historical fact. In 1916, shortly after Einstein published general relativity, physicist Carl Schwarzschild found a solution to Einstein's equations describing what would later become known as a black hole. Remarkably, he completed this work while serving on the Eastern Front during World War I, even by the standards of scientific history. That is an impressive example of multitasking. Most people struggle to answer emails and drink coffee simultaneously. Schwarzschild was deriving revolutionary spacetime geometry during wartime. Now imagine approaching a black hole. From your own perspective, everything feels normal at first. Your watch ticks, your thoughts continue, your heartbeat remains steady. Nothing announces that you are entering one of the most extreme environments in the known universe. But something fascinating happens from the perspective of a distant observer. As you move closer to the black hole's event horizon, the boundary beyond which escape becomes impossible. Your clock appears to slow down, not metaphorically, literally. The distant observer sees your time passing more slowly. The closer you get, the more dramatic the effect becomes. Seconds stretch. Minutes lengthen. Your movements seem increasingly sluggish. Near the horizon, you appear almost frozen. This prediction emerges directly from general relativity and has been confirmed through numerous observations of gravitational time dilation in weaker gravitational fields. A mainstream scientific fact. Clocks positioned closer to massive objects tick more slowly than clocks farther away. Modern technologies such as GPS systems must account for these relativistic effects to maintain accuracy. Think about that for a moment. Two observers can disagree about how much time has passed, not because one is mistaken, because space-time itself allows it. The universe does not contain a single master clock keeping score. Every observer follows their own path through space-time, their own world line, their own experience of duration. And black holes exaggerate this truth until it becomes impossible to ignore. A quirky fringe tidbit emerged from popular interpretations of relativity during the 20th century. Some enthusiasts claimed that black holes were gateways to time travel, portals into alternate realities, or cosmic shortcuts created by advanced civilizations. While such ideas remain speculative and unsupported by evidence, they reveal how naturally black holes inspire the imagination. Historians still argue whether the earliest discussions of black holes underestimated their importance, or whether their significance only became clear after later theoretical developments. As you drift closer to the event horizon in your imagination, another curious realization appears. From the distant observer's perspective, you never quite cross the horizon. You approach it endlessly, slower and slower, closer and closer, yet never fully disappearing, at least not according to the way their observations unfold. Meanwhile, from your own perspective, you continue moving normally. You cross the boundary in finite time. The disagreement is profound. Two descriptions, both valid, both emerging from the same laws of physics. This is one of the reasons black holes occupy such a special place in discussions about time. They expose how deeply the concept depends on perspective. What seems frozen from one viewpoint remains active from another. What appears delayed in one frame proceeds naturally in another. The familiar notion of a universally shared present becomes increasingly difficult to defend. And once again, the idea of a flowing cosmic river begins to dissolve. Because if time can stretch, compress, and differ between observers, what exactly is doing the flowing? Where is the master current? Physics never seems to locate it. Instead, it provides relationships between events. Measurements between observers, geometries within space-time. The flow itself remains elusive, almost suspiciously elusive. Imagine standing beside a waterfall in thick fog. You hear rushing water everywhere. You feel moisture in the air. Yet somehow you never directly see the source. That is often what the passage of time feels like when examined closely. Its effects seem obvious, its existence seems undeniable. Yet whenever physics reaches for the mechanism retreats, a mainstream scientific fact. Black holes continue to serve as laboratories for investigating the deepest questions about gravity, quantum mechanics, information, and the nature of time itself. In fact, one of the greatest unresolved puzzles in physics emerges from black holes' information. Quantum theory suggests information cannot simply vanish, yet black holes appear capable of swallowing information behind horizons. Reconciling these ideas has challenged physicists for decades, and hidden within that challenge may be clues about the true nature of space-time. Some researchers suspect that information, rather than space or time, may be the more fundamental ingredient. If that turns out to be true, the implications could be extraordinary. Time might resemble a useful description rather than a basic component of reality. Much as a wave describes water without being a separate substance, much as a melody describes notes without existing independently of them. And there is something oddly calming about that possibility. Not because it solves every mystery, because it gently shifts perspective. Instead of imagining yourself being carried helplessly by a relentless river of time, you begin to imagine yourself as part of a larger structure, a pattern within space-time, a thread woven into a cosmic tapestry. The thread does not flow, the tapestry simply exists. Yet one question continues to linger. If the universe may be structured rather than flowing, if black holes reveal the flexibility of time, and if physics increasingly struggles to identify a fundamental passage, why does your experience remain so convincing? Why does every second feel like it arrives? Why does every memory feel like it recedes? Why does consciousness create such a powerful impression of motion through time? To answer that, you'll need to leave black holes behind for a while and travel inward instead, not into space-time, into the human brain, because the next part of the mystery may have less to do with the cosmos than with the remarkable machine quietly generating your experience of reality right now. So you turn away from black holes, the event horizons fade into the darkness behind you, and the vast architecture of space-time remains stretched across the cosmos like an impossibly large map. But now the journey changes direction. Instead of traveling farther outward into the universe, you begin moving inward, toward the organ that has been accompanying you through every moment of this discussion. Your brain, because there is an uncomfortable possibility we have been circling for hours now. What if the sensation of time passing is not a property of the universe? What if it is a property of you? A mainstream historical fact. In the late 19th century, psychologists such as William James began systematically studying human consciousness and subjective experience. James famously described consciousness as a flowing stream, an image that still influences discussions of awareness today. The phrase sounds natural, a stream of consciousness, thoughts flowing, moments passing, experiences arriving, yet modern neuroscience reveals something surprising. Your brain is not simply observing reality, it is actively constructing your experience of reality. Right now, billions of neurons are exchanging signals throughout your nervous system. Sensory information arrives from your eyes, ears, skin, and countless internal systems. The brain gathers these inputs and assembles them into a coherent experience. The key word is assembles, not receives. Assembles, a mainstream scientific fact. Sensory information reaches different parts of the brain at different times, yet consciousness typically presents it as a unified experience. The brain continuously integrates delayed signals into what feels like a seamless present. That seamless present feels immediate, but it is not, in a sense. You are always experiencing a carefully edited version of reality. A tiny delay exists between external events and conscious awareness. Your brain hides this delay remarkably well. Like a skilled film editor cutting together thousands of frames so smoothly that you never notice the transitions. A quirky fringe tidbit comes from certain psychological experiments and speculative interpretations suggesting that the brain may sometimes predict incoming information milliseconds before conscious awareness catches up. While the details remain controversial, the findings have inspired debates about how much of experience is prediction rather than direct observation. Historians still argue whether early philosophers intuited these ideas through introspection or whether modern neuroscience has fundamentally transformed our understanding of consciousness. As you sit quietly with this thought, something begins to shift. Imagine watching a movie, the characters move naturally across the screen. Conversations unfold, events seem continuous. Yet you know the motion is an illusion created by individual frames displayed in sequence. Now imagine consciousness working in a somewhat similar way. Not identical, but similar. Instead of perceiving every instant independently, the brain may combine information across short intervals, creating the impression of smooth continuity. You do not experience disconnected snapshots. You experience a flowing narrative. And narratives are something brains excel at constructing. In fact, your mind is constantly building stories, not necessarily fictional stories, interpretive stories. Why something happened, what it means, what comes next. The brain appears deeply invested in creating continuity, which raises an intriguing possibility. Perhaps the sensation of temporal flow emerges from narrative processing. Perhaps consciousness creates a moving present because organizing experience that way proves useful. After all, predicting future events improves survival. Remembering past events improves survival. Building a coherent timeline improves survival. Evolution tends to reward useful perceptions, not necessarily perfectly accurate ones. Consider color. Color feels like an intrinsic feature of reality. Yet what you experience as color is the brain's interpretation of different wavelengths of light. The external world does not contain redness or blueness in the way experience presents them. Similarly, perhaps the external world does not contain temporal flow in quite the way experience presents it. The flow may be an interpretation, an extraordinarily useful one, but still an interpretation, a mainstream scientific fact. Many neuroscientists view perception as an active process in which the brain constructs models of reality using incoming sensory information and prior expectations. That idea has profound implications. Because if perception is a model, then the experience of time may also be part of that model. The brain could be generating a temporal framework that helps organize information efficiently. Not unlike a librarian arranging books on shelves, the shelves do not create the books. They create order. Likewise, temporal experience may create order within consciousness. And suddenly something that once seemed obvious becomes mysterious again. The passage of time feels self-evident, yet its source becomes increasingly difficult to identify. Konzing struggles to find it. Relativity complicates it. Quantum theory questions it. Now, neuroscience suggests that part of the experience may be internally generated. The deeper you look, the more the flowing river begins to resemble a cognitive construction layered upon a deeper reality. That does not make the experience unreal. Pain is real. Joy is real. Music is real. Dreams are real experiences even when their content is imaginary. Likewise, the feeling of time passing is undeniably real as an experience. The question is whether it corresponds directly to a fundamental feature of the universe. And at this point, the answer remains uncertain. Some researchers argue that consciousness merely detects temporal flow. Others argue that consciousness helps create the perception of flow. Still others suspect both views are incomplete. The debate remains open, yet one thing becomes increasingly clear. The universe you experience is not simply given to you. It is interpreted, filled, organized, constructed. And nowhere is that construction more important than in memory, because memory may be the mechanism that gives the past its apparent reality. The reason yesterday feels behind you, the reason childhood feels distant, the reason life appears to stretch along a timeline. If the brain is the storyteller, memory may be the archive from which the story is built. And somewhere within that archive lies another clue to the possibility that time has never truly passed at all. The storyteller now opens its archive. Not a dusty archive hidden beneath a stone library, not shelves stretching endlessly into candlelit darkness. Something much stranger, a living archive, one that rewrites itself every time you visit, one that feels reliable while quietly editing the details, one that helps create your entire sense of personal history. Mirror, if you pause for a moment and examine your experience carefully, you notice something remarkable. You never directly experience the past. You only experience memories of the past. Right now, this very second, you are not standing inside yesterday. You are standing inside the present while accessing information stored within your brain. And that distinction turns out to matter enormously. A mainstream historical fact. In the late 19th and early 20th centuries, psychologists began systematically studying memory, discovering that recollection is not a simple replay of stored events, but a complex process of reconstruction. These findings transformed how scientists understood human experience. For centuries, people imagined memory as something like a warehouse. Events happened, the brain stored them. Later, the brain retrieved them. Still, comforting wrong. Modern neuroscience suggests memory behaves less like a video recording and more like a storyteller rebuilding scenes from fragments. Every time you recall an event, the memory becomes active. And when it becomes active, it can change. Tiny details shift. Emotions alter emphasis. Conks strengthen or weaken. The archive edits itself while you browse it, which means your sense of the past is not a direct window into previous reality. It is an ongoing reconstruction, a mainstream scientific fact. Research has repeatedly shown that memories are reconstructive rather than perfectly preserved recordings. Recalling a memory can alter aspects of it, sometimes subtly and sometimes dramatically. That realization feels almost mischievous. You trust your memories because they feel vivid. The brain, meanwhile, quietly rearranges furniture while insisting everything remains exactly where you left it. A quirky fringe tidbit emerged from early psychological investigations when researchers discovered how surprisingly easy it could be to create false memories under certain conditions. Some participants became convinced they remembered events that never occurred. The findings remain controversial in specific applications, but they demonstrated just how flexible memory can be. Historians still argue whether autobiographical memory should be viewed primarily as historical record or narrative construction, and that debate connects directly to time. Because what gives the past its apparent existence in your experience? Memory. Without memory, the distinction between past and present becomes difficult to maintain. Imagine waking each morning with no recollection of previous days. You would still perceive events, you would still think, you would still experience sensations. But the sense of a long personal timeline would largely disappear. Your identity itself would begin to feel different. The continuity of self depends heavily upon memory, and continuity of self is deeply entangled with continuity of time. Think about how you imagine your life. You probably picture a sequence: childhood, adolescence, adulthood, individual chapters arranged along a timeline. Yet at any given moment, what you actually possess is the present experience plus memories. The past feels real because traces of it remain encoded within you. Those traces create direction, they create narrative, they create the impression of movement from one stage to another. But notice something fascinating. The future does not leave memories. It leaves possibilities, and this asymmetry contributes enormously to your sense that time moves forward. You remember yesterday, you anticipate tomorrow. The difference feels fundamental. Yet from the perspective of the block universe we discussed earlier, both yesterday and tomorrow may simply be different regions of space-time. What changes is your access to information. not necessarily the underlying reality. Imagine walking through a vast museum with a flashlight. The exhibits behind you remain present. The exhibits ahead of you also remain present. But your beam illuminates only a limited region at a time. Likewise, memory illuminates portions of your world line that consciousness has already encountered. The future remains dark not because it does not exist, but because your information about it remains limited. At least, that is one possibility. And it is a possibility that becomes increasingly difficult to dismiss as the night deepens, a mainstream scientific fact. Memory formation involves physical changes in neural networks, creating traces that allow past experiences to influence future behavior. Those traces matter enormously. Without them, learning becomes impossible. Language becomes impossible. Culture becomes impossible. Civilization itself depends upon memory, both individual and collective. Written records are memories. Photographs are memories. Libraries are memories. Even history is a specialized form of memory extended across generations, which brings us to another interesting observation. Human societies spend extraordinary effort preserving the past. Ancient monuments, archives, museums, chronicles, calendars. We are creatures obsessed with continuity, perhaps because continuity helps us navigate reality, or perhaps because continuity reassures us that our lives possess structure. After all, it is comforting to imagine yourself traveling along a path, beginning here, moving there. Progressing steadily through existence, the alternative feels stranger. To imagine your life as an already existing structure, to imagine moments not vanishing but remaining embedded within space-time, to imagine that the past has not disappeared at all, only become inaccessible, like distant cities beyond the horizon. The idea is difficult to prove, difficult to visualize. Yet it continues resurfacing because so many lines of thought seem to point toward it. Relativity, the block universe, entropy, neuroscience, mirror. Again and again, the familiar river of time becomes harder to locate. And still your experience remains convincing because your body itself reinforces temporal order every hour of every day. Deep inside you, biological clocks are ticking, not necessarily proving that time flows, but helping create the rhythm through which life experiences reality. And those clocks are waiting quietly beneath your skin, preparing to reveal yet another layer of the mystery. Beneath every thought, every memory, every sleepy reflection drifting through your mind tonight, another kind of clock is quietly at work, not hanging on a wall, not orbiting in space, not synchronized to atomic standards. A biological clock, several of them, in fact. Tiny rhythms woven into your body so deeply that you rarely notice them until they are disrupted. And these rhythms play a surprisingly important role in how you experience time, a mainstream historical fact. In the 18th century, the French astronomer Jean-Jacques Dortus de Mairan performed an early experiment on plant behavior. He observed that certain plants continued opening and closing their leaves even when kept in darkness, suggesting the existence of internal biological timing mechanisms. The discovery was remarkable because it hinted that living organisms do not simply respond to clocks. They contain clocks. You are carrying one right now. Actually, your body tracks cycles of sleep and wakefulness, hormone release, temperature fluctuations, metabolism, and countless other processes. Together, these rhythms help organize your experience of daily life, a mainstream scientific fact. The human circadian system operates on an approximately 24-hour cycle, coordinated by structures in the brain that respond to environmental cues such as light. When morning light enters your eyes, signals travel deep into the brain. Hormones shift, alertness rises, baby temperature changes. The entire system begins preparing you for daytime activity. Later, darkness encourages a different sequence. The body gradually prepares for rest. At least, that is the plan. Modern technology occasionally responds by handing your biological clock a glowing screen at midnight and saying, "Good luck." The relationship between humanity and sleep has become one of history's longest-running passive-aggressive negotiations. Yet, despite late-night scrolling and questionable life choices involving caffeine, your internal timing systems remain astonishingly sophisticated. And here is where things become interesting for our discussion. Biological clocks do not measure some universal cosmic flow. They measure patterns, cycles, relationships, changes, just as ancient sundials tracked shadows rather than time itself. Your body tracks physiological processes rather than any fundamental river flowing through reality. This observation may seem subtle, but it matters, because much of what feels like the passage of time may arise from internal change. You feel older because your body changes. You feel seasons because environments change. You feel days because biological cycles repeat. Experience becomes structured through rhythm. A quirky fringe tidbit comes from historical folklore surrounding body clocks. Various traditions claimed that specific organs followed mystical schedules throughout the day, assigning particular hours to different bodily functions. Modern science does not support these precise systems, but their existence reveals how long humans have recognized internal rhythms. Historians still argue whether ancient observations of biological timing were primarily medical insights or symbolic cultural frameworks. As you continue reflecting, consider a simple question. How would time feel if your body possessed no rhythms at all, no sleep cycles, no heartbeat, no metabolism, no aging, no biological change? The question is difficult to imagine because biological timing saturates your experience. Every day arrives wrapped in recurring patterns: wakefulness, hunger, fatigue, rest. These cycles create landmarks in consciousness. Without landmarks, navigation becomes difficult. And without navigation, the sensation of moving through time might look very different. Imagine sailing across a perfectly calm ocean beneath a featureless sky. No stars, no waves, no wind, no horizon. Movement would become surprisingly hard to detect. Likewise, many of your temporal intuitions depend upon change. The body changes, the environment changes. Memories accumulate, expectations evolve. Together they generate the impression of forward movement. Yet none of these necessarily require time itself to flow. They only require differences between states. That distinction keeps returning, again and again. Like a refrain in the background of tonight's journey, a mainstream scientific fact. Aging results from countless biological processes occurring over time, including cellular changes, genetic regulation, and environmental influences. These processes provide some of the most powerful evidence people use when intuitively judging the passage of time. And understandably so, your body tells a story. Childhood becomes adulthood. Youth becomes maturity. Photographs accumulate. Wrinkles appear. Hair occasionally decides to pursue independent career opportunities elsewhere. The evidence of change feels overwhelming. But remember what we've discovered. Chance does not automatically prove temporal flow. A photograph album contains many images arranged sequentially. The sequence exists, the pages exist, yet the album itself is not flowing. You create movement by turning pages. Likewise, a world line in space-time may contain many stages of a life without requiring a universal river carrying those stages forward. The distinction remains subtle, but increasingly difficult to ignore. And there is another reason biological clocks matter. They reveal how deeply human experience depends upon measurement. Not cosmic measurement, practical measurement. The body measures cycles. The brain measures intervals. Civilizations measure seasons. Again and again, what we call time appears closely tied to systems of organization, ways of tracking change, ways of imposing structure, ways of coordinating experience. This realization prepares you for the next stage of the journey, because once biological rhythms become social rhythms, humanity begins building calendars, clocks, schedules, and entire civilizations around them. And somewhere in that process, a curious transformation occurs. A feeling becomes a measurement, an experience becomes a standard, and time, which may never have truly flowed at all, becomes something people can sell, waste, save, spend, schedule, divide, and obsess over. An impressive achievement for a phenomenon that might not actually be moving anywhere. The biological rhythms continue their quiet work beneath your skin. Your heartbeat keeps its patient cadence. Your breathing rises and falls. Hormones drift through invisible cycles. And somewhere along humanity's long journey, those natural rhythms escape the body and become something much larger. They become civilization, because once people begin living together in large groups, timing becomes more than a personal experience. It becomes a shared agreement, a mainstream historical fact. Some of the earliest formal calendars emerged in ancient agricultural societies that depended on seasonal cycles for planting and harvesting. In places like ancient Egypt and Mesopotamia, careful observation of the sky allowed communities to coordinate food production, religious festivals, and political administration. The need was practical. Seeds planted too early could fail. Seeds planted too late could fail. Nature was not interested in excuses. The crops certainly weren't. So people watched the heavens. They tracked the sun. They followed the moon. They recorded recurring celestial patterns. And gradually, something fascinating happened. Human beings transformed observation into organization. The sky became a schedule. A quirky fringe tidbit comes from various ancient cultures that treated calendars as living entities possessing spiritual significance. Certain dates were considered inherently fortunate, dangerous, or cosmically charged. Modern historians view many of these beliefs as symbolic systems rather than literal truths, but they reveal how deeply humans connected timekeeping with meaning. Historians still argue whether early calendars were primarily scientific tools that later acquired religious significance, or religious systems that gradually evolved into practical instruments. Either way, the result was transformative. Entire societies began coordinating around shared temporal frameworks, harvests, ceremonies, trade routes, tax collection, military campaigns. Everything benefited from synchronization. Suddenly, when became almost as important as where. And yet, beneath all this impressive coordination, a subtle question remained hidden. Were people measuring time itself, or merely measuring change? The distinction rarely mattered in daily life. If a farmer knew when to plant crops, philosophical uncertainty could wait until after harvest. But the question never disappeared completely. It lingered beneath the surface. And as civilizations grew more sophisticated, so did their methods of measurement: water clocks, hourglasses, mechanical clocks, pendulums, eventually atomic clocks. Each generation built more precise tools. Each generation measured intervals more accurately, yet none of these inventions necessarily answered what time actually was. Imagine inventing increasingly sophisticated rulers without ever determining the true nature of length. You could measure brilliantly while still misunderstanding the underlying concept. Something similar may have happened with time, a mainstream historical fact. During the Middle Ages and early modern period, mechanical clocks spread across Europe, gradually transforming social life by introducing increasingly standardized schedules. Before widespread clocks, daily life often followed natural rhythms: sun's rise, sunset, seasonal patterns, local customs. Then clocks arrived and began carving experience into increasingly precise segments: hours, minutes, seconds, schedules, deadlines, appointments. The clock became a powerful social force. In many ways, modern civilization runs on synchronized agreement. Trains arrive according to schedules. Businesses open according to schedules. Schools operate according to schedules. Entire economies depend upon coordinated timing. You might even say humanity collectively decided to place reality inside a planner. And once that happened, there was no turning back. The funny part is that people now talk about spending time, saving time, wasting time, investing time, and losing time. Time has become almost currency-like, which is quite an accomplishment for something that physicists still struggle to define. Imagine explaining that to an alien civilization. Yes, we organize our entire society around a mysterious phenomenon that may not fundamentally exist in the form we perceive it. The aliens would probably nod politely and back away slowly. A mainstream scientific fact. Modern international timekeeping relies on highly precise atomic clocks that define units such as the second, using predictable atomic transitions. Atomic clocks are astonishingly accurate. Some would lose less than a second over millions of years, and yet even their precision does not settle the philosophical mystery. An atomic clock measures regular physical processes. It does not directly reveal whether time flows. It reveals consistency, repetition, structure. Again, the same theme appears. Measurement tracks change, not necessarily passage. This distinction becomes increasingly important as our journey continues, because human beings often mistake the map for the territory. Calendars feel like time, clocks feel like time, schedules feel like time, but perhaps they are only representations, useful representations, necessary representations, yet representations nonetheless. Think of a globe sitting on a desk. It helps you understand Earth. It allows navigation. It organizes information. But the globe is not the planet. Likewise, clocks help organize reality. They coordinate activity. They measure intervals, but they may not reveal the deepest nature of temporal existence. A quirky fringe tidbit emerged during various reform efforts throughout history when governments attempted to redesign calendars entirely. Revolutionary France briefly experimented with a decimal calendar system. Other proposals sought perfectly rational divisions of time. Most ultimately failed because human habits proved more stubborn than mathematical elegance. Historians still argue whether standard timekeeping primarily reflects natural reality or social convenience. The answer may be both, and that duality reveals something profound. Time as experienced and time as measured are not necessarily identical. Your internal experience stretches and compresses. A joyful hour vanishes. A boring meeting achieves geological timescales. Meanwhile, clocks remain indifferent. They continue counting, steady, unemotional, mechanical. The difference reminds you that temporal experience and temporal measurement occupy distinct domains. One belongs to consciousness. The other belongs to coordination. And somewhere between those domains lies one of the oldest debates in human thought. A debate that philosophers have pursued for centuries. Does only the present exist? Or are past, present, and future equally real? The answer may determine whether time truly passes at all. And waiting just ahead are thinkers who have spent generations arguing over that very question, often with remarkable confidence considering how mysterious the subject remains. The clocks continue ticking, calendars continue turning, schedules continue multiplying like particularly ambitious rabbits. Civilization hums along, confident that it knows what time is because it can measure it. Yet beneath all that confidence lies a question that has occupied philosophers for centuries. What actually exists? Not what feels real, not what seems obvious, what exists. And surprisingly, when philosophers begin examining time, agreement vanishes almost immediately. A mainstream historical fact. Philosophers have debated the nature of time since antiquity, with major contributions from thinkers such as Aristotle, Augustine of Hippo, and many others across cultures and centuries. The debate eventually crystallizes into two broad positions, presentism and eternalism. The names sound like rival wizard schools. In a sense, they are. Each attempts to explain the deepest structure of reality. Presentism feels closest to common sense. According to presentism, only the present moment truly exists. The past existed, the future will exist. But right now, only the present is real. Yesterday is gone, tomorrow has not arrived. Reality consists solely of the current moment. Most people instinctively lean toward this view. After all, it matches everyday experience. You experience now, not last week, not next year. Now Sybil, comforting, intuitive, and potentially wrong, because eternalism offers a radically different picture. According to eternalism, past, present, and future all exist equally. The universe resembles the block universe we encountered earlier. Events do not come into existence and vanish. They simply occupy different locations within spacetime. Your childhood still exists. Your future still exists. This moment exists. All are equally real components of a larger structure. The difference lies in perspective, not existence, a mainstream scientific fact. Many physicists and philosophers argue that relativity fits naturally with eternalist interpretations because relativity challenges the notion of a universal present shared by all observers. And that is where the argument becomes especially interesting. Presentism feels intuitive. Eternalism often fits more comfortably with modern physics. The two do not align easily. Imagine a gigantic novel. Presentism says only the page currently being read exists. The previous pages have vanished. Future pages do not yet exist. Eternalism says the entire book exists simultaneously. The reader merely experiences it sequentially. Both views capture something important. Both encounter difficulties. A quirky fringe tidbit comes from certain mystical traditions that describe all moments as eternally present within a higher reality. Although these ideas emerge from spiritual rather than scientific frameworks, they occasionally resemble aspects of eternalist thinking in intriguing ways. Historians still argue whether similarities between ancient metaphysical traditions and modern eternalism reflect genuine conceptual overlap or merely superficial resemblance. As you drift through this debate, notice how deeply it affects the original question: has time truly passed? A presentist would answer yes. Moments genuinely come into existence and then disappear. Passage is fundamental. Reality itself changes. An eternalist might answer differently. Nothing passes, nothing vanishes. Events simply exist within space-time. The sensation of passage emerges from conscious experience moving through an already existing structure. The disagreement is profound, and neither side has achieved universal victory. One reason the debate persists is that both perspectives capture aspects of experience. Life certainly feels dynamic. Moments appear, moments recede, choices seem open, the future feels uncertain. These intuitions support presentism, yet relativity repeatedly undermines the idea of a single universal present. Observers moving relative to one another can disagree about which distant events are occurring now. That observation supports eternalism, and so the discussion continues, generation after generation. Argument after argument, book after book, coffee after coffee, entire academic careers have been built upon politely disagreeing about whether tomorrow already exists. Which, when you think about it, is a wonderfully human activity, a mainstream historical fact. Debates concerning the reality of past, present and future remain active in contemporary philosophy, with no consensus accepted by all scholars. That lack of consensus may initially seem disappointing, but perhaps it should feel encouraging. After all, unresolved questions indicate that genuine mystery remains, and time remains one of the greatest mysteries available. The deeper you examine it, the stranger it becomes. The river becomes a structure. The structure becomes information. Information becomes relationships. And passage itself grows increasingly elusive. Imagine standing beside a railroad track stretching beyond the horizon. Each section of track exists simultaneously, yet a train traveling along it experiences a sequence of locations. Perhaps consciousness functions similarly, not creating the track, not creating the stations, simply encountering them in order. Of course, presentists would object immediately. They would argue that the stations ahead do not yet exist. The train is helping create reality as it proceeds, and perhaps they are correct. The evidence remains incomplete, the mystery remains open. Still, one observation continues to linger. Whenever physics describes reality at its deepest levels, the language of passage often fades. Equations describe relationships, structures, geometries, fields, probabilities. The moving present becomes surprisingly difficult to identify, almost as though the flow belongs more to experience than to the universe itself. And that possibility becomes even more intriguing when paired with a question that would have sounded like science fiction not long ago. What if time is not fundamental? What if it emerges from deeper computational rules? What if reality itself behaves more like information processing than a flowing temporal stream? The idea remains speculative, yet it has become increasingly difficult for researchers to ignore. And somewhere ahead, beyond philosophy and beyond traditional physics, that possibility waits quietly in the dark. The railroad track stretches onward into darkness. Each station appears fixed, each segment exists where it is, and the question now becomes even stranger than before, not whether time passes, not whether the future already exists, but whether time itself might emerge from something deeper, something beneath space-time, something beneath the universe as we normally imagine it. A mainstream historical fact. During the late 20th and early 21st centuries, advances in computer science, information theory, and theoretical physics inspired new ways of thinking about reality. Researchers increasingly began exploring whether information might play a more fundamental role in nature than previously suspected. This shift did not happen because scientists suddenly decided the universe was a computer. Reality is rarely that cooperative. Instead, the idea emerged because information kept appearing in unexpected places: black holes, quantum mechanics, thermodynamics, cosmology. Again and again, information seemed oddly important, almost foundational. And once information enters the conversation, an intriguing possibility appears. Perhaps space-time itself emerges from underlying informational relationships. Perhaps time is not fundamental. Perhaps it is produced, a mainstream scientific fact. Several modern theoretical frameworks investigate whether space-time may emerge from more basic structures, including approaches involving quantum information, quantum gravity, and network-like mathematical descriptions. Notice how familiar this pattern has become. Earlier we discussed temperature. Temperature feels fundamental, yet it emerges from countless molecular motions. We discussed waves. Waves feel real, yet they emerge from water. Likewise, time may feel fundamental while emerging from deeper processes. The idea remains speculative, but it is no longer merely science fiction. Serious researchers actively explore versions of it. A quirky fringe tidbit comes from simulation hypotheses proposing that reality might resemble an enormous computational system. While such ideas attract public fascination, they remain highly speculative and currently lack direct evidence. Nevertheless, they illustrate how deeply questions about information and reality have penetrated modern thinking. They still argue whether future generations will view today's information-centered theories as revolutionary breakthroughs or temporary stepping stones toward entirely different ideas. As you sit quietly beneath the stars of imagination, consider what emergence really means. Suppose you zoom into a single pixel on a digital image. You find information, pause, data, but not the picture itself. The image emerges only when countless pixels interact. Likewise, perhaps time emerges only when deeper structures interact in particular ways. If so, asking whether time passes may resemble asking whether a wave passes independently of water. The wave is real, its behavior matters, yet its existence depends on something deeper. This possibility changes perspective dramatically. Instead of imagining yourself trapped inside a flowing river of time, you begin imagining yourself within a vast informational structure, a network of relationships, a pattern among patterns. The universe becomes less like a clock and more like a tapestry, or perhaps more accurately, a computation unfolding according to rules that consciousness experiences as temporal progression. Now, before your sleepy brain decides it has accidentally wandered into a philosophy convention, remember that none of this is settled science. The mystery remains open. Researchers continue debating, testing, calculating, arguing, occasionally staring at whiteboards with expressions suggesting reality has become personally offensive. That, too, is part of the scientific process, a mainstream scientific fact. No currently accepted theory successfully unifies quantum mechanics and gravity into a complete framework, meaning fundamental questions about space-time and time remain unresolved. And yet something remarkable has happened during our journey. Notice how often the same theme keeps returning. Relativity weakens the idea of a universal present. The block universe treats events as parts of a structure. Quantum gravity hints that time may disappear from fundamental equations. Entropy explains temporal direction without requiring temporal flow. Neuroscience suggests that the sensation of passage may be constructed. Memory creates continuity. Biological rhythms create organization. Calendars create coordination. Philosophy questions whether only the present exists. Again and again, the river becomes harder to locate, not impossible, just elusive, as though the closer you approach it, the more it dissolves into relationships and patterns. Imagine examining a rainbow. From a distance, it appears solid and obvious. You can point to it, describe it, photograph it. Yet when you approach, you discover it is not an object in the ordinary sense. It emerges from geometry, light, perspective, and observation. Perhaps time resembles that, a genuine phenomenon, a meaningful experience, but one whose apparent solidity depends upon deeper conditions. A quirky fringe idea occasionally discussed in speculative circles suggests that consciousness itself might play a central role in generating temporal experience. Most scientists remain cautious about such claims because evidence remains limited. Yet the persistence of such ideas reflects how difficult it is to separate time from awareness. Historians still argue whether future breakthroughs will arise primarily from physics, neuroscience, philosophy, or some combination of all three. Perhaps the answer requires all of them. Because time occupies an unusual position, it is simultaneously a physical concept, a psychological experience, a biological rhythm, and a philosophical mystery. Few subjects touch so many domains at once. And now, after wandering through all these layers, you approach the final synthesis, the place where the pieces begin fitting together, not perfectly, not completely, but enough to glimpse a startling possibility. What if time has never truly passed? What if the passage you experience is not a property of the universe itself, but a feature of how conscious beings encounter reality? What if the moments you call past remain embedded within space-time? What if the future is not being created but discovered? What if existence is less like a river and more like a landscape so vast that awareness can only explore it one view at a time? The answer remains uncertain, but the possibility waits quietly ahead. And as the night deepens, it becomes increasingly difficult to dismiss. The landscape stretches around you now, not a river, not a conveyor belt carrying moments away into darkness. A landscape, vast, silent, complete, and after everything you have encountered tonight, the ancient shadow clocks, Einstein's space-time, the block universe, entropy, memory, biological rhythms, philosophy, black holes, and the strange hints emerging from modern physics, you arrive at a possibility that once seemed impossible to take seriously. What if time has never truly passed at all? Not because clocks are wrong, not because change is imaginary, not because experience is fake, but because the passage itself may not be a fundamental feature of reality, a mainstream historical fact. Throughout history, many thinkers have questioned the nature of temporal passage, from ancient philosophers to modern physicists. The debate has never disappeared because every answer seems to reveal deeper questions, and perhaps that persistence tells us something important. Maybe the mystery survives because it touches the limits of human intuition. After all, nearly everything about your experience encourages belief in temporal flow. You remember yesterday, you anticipate tomorrow, you watch seasons change, you see faces age, you hear songs begin and end. Life feels dynamic, moving, unfolding. Yet every major stop on tonight's journey has quietly challenged that intuition. Relativity weakens the idea of a universal present. The block universe suggests all moments coexist. Quantum gravity hints that time may not be fundamental. Entropy provides direction without requiring flow. Neuroscience reveals how experience is constructed. Mirror creates continuity. Biological clocks organize perception. Calendars coordinate societies. Again and again, the same possibility emerges. The passage may belong more to awareness than to reality itself. Imagine standing inside an enormous library. Every book already exists. Every page already exists. The stories do not write themselves as you read them. They are complete. Yet reading creates the experience of progression. Surprise, anticipation, narrative. Likewise, perhaps consciousness encounters reality sequentially, generating the feeling of movement through a structure that already exists. A quirky fringe tidbit comes from certain speculative interpretations of physics, suggesting that consciousness might be analogous to a spotlight moving across space-time. Most physicists do not endorse such literal models, but the metaphor remains useful because it captures the distinction between structure and experience. Historians still argue whether future scientific revolutions will reinforce or overturn eternalist views of time. For now, uncertainty remains. And uncertainty is not failure, it is simply honesty. Because the deeper we investigate, the more complicated reality becomes. Perhaps the universe is a block universe, perhaps it is not. Perhaps time emerges from information. Perhaps it does not. Perhaps consciousness creates temporal flow. Perhaps it merely observes it. The answers remain incomplete. Yet something valuable emerges even from uncertainty, a change in perspective. You spend much of life worrying about time running out, hours disappearing, years slipping away, moments being lost forever. Those concerns are deeply human. Entire civilizations are built around them. But if reality is closer to a landscape than a river, then perhaps the past is not truly gone. Perhaps moments do not vanish. Perhaps they remain woven into the structure of space-time, permanent, unmoving, still part of existence. The child you once were, the conversations you barely remember, the afternoons that seemed ordinary at the time, the people who crossed your path, the laughter, the mistakes, the victories, the embarrassments that still occasionally visit at 3 in the morning for no apparent reason. All of it appended somewhere within the structure, not necessarily accessible, but not necessarily erased. That possibility carries a quiet kind of comfort. Not certainty, comfort, because certainty remains beyond reach, a mainstream scientific fact. No current theory provides a definitive answer to whether temporal passage is fundamental or emergent. The question remains one of the deepest unresolved issues at the intersection of physics, philosophy, and neuroscience. and perhaps it will remain unresolved for some time. Humanity may discover new theories, new observations, new mathematics. Future generations may look back on our understanding of time the way we look back on ancient maps. Useful, impressive, incomplete. Reality has surprised us before. It will almost certainly do so again. For now, though, you have traveled a long way, from shadows on stone walls to the edge of the observable universe, from ticking clocks to the possibility that nothing has ever truly ticked at all, from everyday intuition to the strange frontier where science and philosophy meet. And there, at that frontier, you find not an answer but a view of reality that is wider than it seemed when the journey began. A view in which the universe may be less like a story unfolding and more like a masterpiece already painted. You experience one brushstroke at a time. The painting itself remains whole. And now, as the journey gently slows, the night grows softer. The questions become quieter. The need for answers becomes lighter. You no longer need to solve time before sleep arrives. You only need to rest within the mystery. The room around you feels still. The air moves softly. Perhaps a fan hums somewhere nearby. Perhaps distant sounds drift through the darkness. You notice your breathing, slow, steady, easy. The great clocks of civilization continue turning somewhere beyond your walls. Schedules continue. Calendars continue. The world remains busy. But for this moment, none of that asks anything from you. You can simply rest. Imagine the vast landscape of spacetime stretching beneath a sky filled with silent stars, every moment of every life shining somewhere within it, every memory, every possibility, every story, not rushing, not fleeing, simply existing within a reality far larger and stranger than human intuition ever expected. And as you drift towards sleep, the landscape grows quieter still. The stars soften. The distances fade. The questions loosen their grip. You do not need to chase tomorrow. You do not need to hold yesterday. You can simply float here, suspended within the mystery. While the universe keeps its secrets a little longer, the darkness becomes gentler, the thoughts become slower, the edges of awareness soften like waves dissolving into a calm shore. And perhaps, just perhaps, if time has never truly passed, then this moment is not slipping away at all. It is simply another beautiful place within the landscape waiting. Quiet still. 300-word wind down now. Let the landscape grow dim, not disappear. Just fade into the distance. The stars remain overhead, scattered across an endless sky, but their light feels softer now. Less like questions and more like companions. You no longer need to follow every thought. You no longer need to untangle every paradox. The universe has carried mysteries for billions of years. It can carry them through the rest of tonight. Allow your attention to settle gently. Feel the weight of the bed beneath you. Feel the quiet rhythm of your breathing. Notice how naturally each breath arrives, how naturally each breath leaves. No effort, no urgency, just a calm pattern unfolding on its own. The great debates of physics can wait, the equations can wait, the unanswered questions can wait. Tonight is not about solving reality, it is about resting inside it. Imagine yourself standing once more beside that vast cosmic landscape, not searching, not traveling, simply observing. The mountains of moments stretch beyond the horizon. The valleys of memory rest peacefully below. The distant future glimmers faintly in the starlight. The past rests quietly behind. Nothing rushes. Nothing demands, everything simply is. And within that stillness, your thoughts become lighter. The landscape grows softer. The stars blur gently into darkness. The darkness becomes calm. The calm becomes sleep. So let the universe remain vast. Let time remain mysterious. Let tomorrow arrive whenever it arrives. For now, there is only quiet, only rest, only the soft comfort of drifting deeper and deeper into peaceful sleep beneath a sky that has all the time in the world.